Hello everyone and thank you for joining us in this EMworks webinar. We shall show you how to use HFWorks to efficiently reduce the mutual coupling between antenna elements. Our agenda is as follows. A brief discussion about our products and services, followed by the main technical presentation. After the technical presentation, we will brief you about licensing, services, and various learning resources offered by EMworks. Then comes the questions and answers period. At that point, Dr. Kabir will go on stage and answer your questions. You may then type your questions in the chat section. All of your questions will be answered. All of our products are integrated into SolidWorks, the #1 3D CAD package. Some of our products are equally integrated in Autodesk Inventor. Why? There are a couple of reasons, including, we want to concentrate our effort on what we know best. Electromagnetic simulation. We don't want to reinvent the wheel. In other words, why should we develop a CAD while there are excellent professional CADs? Developing a CAD requires much more human and financial resources than a simulation software like ours. Indeed, all simulation companies that made the mistake of developing their own CAD ended up with a primitive and even mediocre software. Why bother about learning a new primitive CAD? Just use your professional CAD and start simulating right away. You can easily collaborate with other departments in your company since all of you use the same CAD model. Some companies that have their primitive CAD claim that you can import files from popular CADs such as SolidWorks or Inventor. It is true. You can import. However, oftentimes you would need to heal, stitch, or clean the geometry because of compatibility issues. Furthermore, if and when you need to make the smallest modification, you must start all over again. We hope that you understand now why we stayed away from developing our own CAD and, instead, relied on the professional CADs. We believe that we convinced you. You may ask now, what are the other companies that provide an electromagnetic software package that are fully integrated in a professional CAD such as SolidWorks or Inventor? Look no further. EMworks is the first and the only company that provides electromagnetic software as add-in to SolidWorks and Inventor. As a matter of fact, the integration in SolidWorks dates back to 2007 and in Inventor to 2012. Consequently, we have more products integrated in SolidWorks which are all gold certified. Our products and services are as follows. EMS is a 3D electric and magnetic field modeling software for frequency ranging from DC to few hundred megahertz. It covers many applications like insulators, cables, bus bars, permanent magnets, actuators, circuit breakers, transformers, and motors. HFWorks is an electromagnetic simulation software for RF, microwave, high-frequency, and high-speed electrical and electronic devices. It covers many applications including a wide range of antennas, resonators, filters, connectors, and waveguides. EMworks 2D is a 2D and axisymmetric electric and magnetic field modeling software for frequency ranging from DC to few hundred megahertz. It covers the same applications as EMS. Motor Wizard is a template-based motor design software. It offers analytical and finite element analysis for BLDC and permanent magnet motors. In addition to these solvers, we offer several multi-physics modules including motion, stress analysis, thermal analysis, electric circuits, and ECAD. Let's move now to the feature technical presentation.
An efficient technique to reduce the mutual coupling between antenna elements. The miniaturization of antenna arrays imposes on the designer to place a large number of elements in a small footprint. This action gives rise to the so-called mutual coupling between antenna elements. The mutual coupling causes crosstalk and distortion, leading to the deterioration in the antenna performance and potential distortion of the radiation pattern. We won't exaggerate if we say that such mutual coupling is the biggest obstacle to the miniaturization of antenna arrays. Therefore, when designing antenna arrays, we should take into consideration this phenomenon and try to reduce it. There are different techniques to reduce the mutual coupling. The so-called meander-line slot is the most recent and most promising technique. This meander, zigzag, or twisted slot is inserted between the antenna patches on the bottom ground plane to suppress the surface currents. The off-diagonal value of the S matrix, such as S21 for a 2-ports device, indicates the amount of coupling between different elements. The lower is the value of the off-diagonal term, the lower is the coupling between the elements. S21, for example, is the preferred metric to quantify the said coupling. In addition, the near-field plot of the electric field around the antennas is also another metric to quantify the coupling. To study this important topic, we call upon EMworks high-frequency simulator, HFWorks. We will use a simple 2x1 patch array antenna, with and without meander line, as an example to illustrate this technique. Since HFWorks is an add-in to SolidWorks, the number one 3D CAD software, the creation and modification of the geometry is as easy as a pie. Therefore, we skip the geometry creation part and dive straight into HFWorks. Since we will use S21 as the main metric for the coupling, the antennas module of HFWorks is invoked. To add a new antenna study, right-click on the project name and choose Antennas. Give it the name of meander-line. Click on the Frequency Sweep tab. Enter 4.7 GHz for the start frequency and 5.2 GHz for the end frequency. Enter 51 for the number of frequency points. No need to check the other tabs. The default is adequate for this application. Click OK. A new antenna study is added to the HFWorks manager tree. Let's apply the material for each body. Right-click on Airbox to apply air. Similarly, you can follow the same procedure to apply material to all other parts. Since we applied materials in a previous study, just drag and drop materials from the previous study with meander-line to materials in this study. Let's apply the necessary boundary conditions. We have two antenna elements. So, we need to set two excitation ports. Port 1 is excited and port 2 is terminated with 50 ohms. Right-click on Boundary Conditions and choose Port. Apply port 1 on the circular face of Arlen. It is a simple wave port. Click OK. Click on Boundary Conditions and choose Lump Port with an impedance of 50 ohm. Apply port 2 on the other face. Click OK. Click on Boundary Conditions to add perfect electric conductor boundary. Choose the bottom face of the substrate which presents the ground plane except the meander line slot and the inner and outer faces of coaxial part. Apply perfect electric conductor boundary on the antenna patches which are printed on the top face of the substrate. We are left only with the radiation's boundary conditions. Click on Boundary Conditions, choose Radiation and add all the outer faces of the airbox. To create another study without meander-line, just copy the above study. Give it the name No Meander-line. All input parameters given to the meander-line study remain the same, except the meander-line slot. Edit the perfect electric conductor boundary. Add the meander slot face to the list of existing faces. It is equivalent to eliminating the meander line because the ground place is all metallic now and has no slot. All the pre-processing is now complete, and we are ready to run the studies. Right-click on a study name and choose Run. Solving will take time. Let's instead examine existing studies that were run previously. After the run is complete, Results folder is created and contains different type of results. Circuit Parameters folder contains the results table and 2D plots. Antennas Parameters folder contains the far-field results such as gain, directivity, efficiency, etc. Electric field and magnetic field folders contain the near electric and magnetic fields in the entire model. Port fields folder contains the electric and magnetic fields on the ports. Loss density and total loss folders contain the volume and surface losses inside the structure. Double-click on the results table. It contains all circuit parameters for all frequencies. Click Close. Double-click on the far-field results table. It contains all antenna parameters for the central frequency. Right-click on the Plots folder and add a new 2D plot. Choose All from Source. Choose S21 from Parameters and click Add. Click OK. The plots of S21 versus frequency appear for the meander line and no meander line studies. S21 at 4.9 GHz is around 7.5 dB and 26 dB without and with the meander line, respectively. The S21 graphs clearly show that adding meander line slots greatly improves the isolation between the antenna elements. Another metric to verify the isolation is the plot of the near electric field. From the electric field folder, we can create different types of plots: fringe, vector, or streamline. To show the fringe plot of the electric field, just click on the electric field icon. The magnitude of the electric field is color-coded, where the red color is the maximum and the blue color is the minimum, as shown on the legend on the right side of the plot. To animate the electric field plot, right-click on the electric field icon and choose Animate, as shown. To show the vector plot of the electric field, just click on the second icon with the vector symbols, as shown. To show the section plot of the electric field, just click on the thread icon with the section symbols, as shown. To animate the section field plot, right-click on the section field icon and choose Animate versus Section Cut, as shown. Similarly, you can plot the magnetic field, the port fields, and the loss density, as shown. To plot the 3D gain pattern, just click on the polar plot icon, as shown. Last but not least, you may generate a report that summarizes all of your work. Right-click on Reports folder and generate. Customize your report and choose either HTML or Words format. Click OK. Let's now compare the electric field plots with and without the meander line. This one belongs to the antenna without meander line. This one belongs to the antenna with meander line. From these two plots, the near electric field plots on the top plane show a reduction in the coupling between the elements if a meander line is used. Hence, the meander line is recommended to be used for reducing the coupling between elements in antenna arrays. A tool like HFWorks is indispensable to design antennas and study the mutual coupling between antenna elements. You cannot guess it. You must simulate it.
Thank you everyone for bearing with us. And I hope that you have learned from the featured technical presentation. Let me briefly touch upon the licensing structure offered by EMworks. We offer 3 different programs: commercial, academic, and startup programs. Each program has its own benefits and requirements. For the commercial program, we offer perpetual licenses. Our licensing structure is usually annual based for the rest of the programs. We have a combination of free and paid licenses for students, academics, mentors, lecturers, and professors based on the program they choose. For startups, we offer a very interesting and generous program that saves you money for other startup expenditures. Learning resources. EMworks offers you various free learning resources, a standard help and step-by-step tutorials, a demo viewer that gives you a head start by accessing many predefined examples and tutorials, regular webinar series on trending electromagnetic topics. Like today's webinar, we regularly post several application notes, blogs, and videos on our web page and social media channels. An annual user conference where you can exchange views and experience with other fellow users. Paid and free web and in-person training. Monthly newsletter to update you about the latest releases, webinars, and other activities. Support and services. Our support service is the strongest point that I can mention in this presentation. We always have your back before and after sales. We offer one-to-one web demo sessions to give you a head start and shorten your learning curve. You may even run a benchmark for you if you want to skip the trial option. We offer consulting and design engineering services. We may even propose to you a new design as per your requirement or refine and optimize your existing design. Featured customers. These are just few of our respected clients. These big names, that come from various industries are true testimonial for the quality of our products and services. I encourage every one of you to try our software and experience its power and ease of use. We offer 2 weeks of free trial license. You may opt for a benchmark instead of a trial license. Please visit our webpage at www.emworks.com. Go to our Contact Us page. Fill in your information and submit your request. We will contact you promptly. On behalf of EMworks, I would like to thank all of you for attending this webinar. Feel free to contact us after this webinar to get more information on our products. Now we pass to the questions and answers period. Please type your question in the chat section on the right of the screen. I kindly request Dr. Kabir to go on stage and answer the questions.